Hi, Jeff Curry here, and I'm just going to do a quick presentation that sort of explores the concept of art and science in medical radiation sciences and how that might sort of weave into us having a profession or a craft, so looking at the craft of medical radiation science. So some might argue, and certainly I've heard these arguments in the past, that the art of our jobs has been supplanted by the science. So if we think about an old radiographer who just sort of intuitively knew what settings to set for a patient of a certain body habitus, and there was no hit and miss, is that they usually got it right. Whereas nowadays is that, we sort of, they'll do the x-ray and then adjust the settings afterwards because it's all digital radiography. And so that art has sort of been lost. And in nuclear medicine, it's the same, that we just knew that before the digital environment came along, that when you injected a patient to look for a dynamic scan, for example, and you had 16 images on the screen to capture that dynamic, that if you started the acquisition too soon or too late, that you'd miss it. And so the art of knowing that you inject the patient and when to hit the start button so that you actually use those 16 I guess spots on the film, because you don't get a second chance at it. Is if you start it too late, then you miss it. If you start it too early, then you'll run out of space before you end up with the entire dynamic study. And there's a whole raft of those examples that we've sort of heard people say, oh, the art is gone now. This used to be an art form. And we often hear also that the art of the jobs has disappeared or been replaced by the science. So that example is a really good example of it, that the idea of digital technology has sort of taken away the art of getting things right the first time, getting the settings right the first time, having the capacity to not only threshold images, but to reorganize images and annotate them and put them in different orders if we made a mistake. And so we hear that sort of discussion going along across all the medical radiation sciences. So part of that's been driven by the rapid developments that have occurred in medical radiation sciences, the emergence of computing technology that's caught up with some of the instrumentation technology, but also formalization of protocols and procedures. The way that we do things is more managed, it's more evidence-based now than built on intuition. And so maybe the art and science domains haven't disappeared, they've just shifted. So I'm going to sort of argue that the art is still there in our jobs. It's just different. It's in a different place to what it used to be. And so this is just a schematic representation of what I mean by art and science. People talk about the left brain, right brain, and all those sorts of things. But if we sort of think about the science being, that logic, that analysis and communication, that can be not only how we do the procedure, but also business analytics go along with those, versus art being more intuitive and more creative and built around emotions. So when we think about art, we think about warm, fuzzy feelings. That's a bit of a generalization. And some people might be insulted by that as well. But it's actually the warm, fuzzy zone. So it lies in intuition. Intuition's informed by science and education and experience, but it also is connected to things like mood. The art recognizes that the end product or outcomes can be different between different patients and different events. So it means that two people could be doing the same task and end up with a different outcome, and that's okay. The end point of the art is defined by a sense or a feeling of the task being done. And that's really important. We feel like we've finished the job. We feel like we've done what was meant to be done. And as a result, you can end up with different outcomes. So it's that warm, fuzzy sort of feeling that things are nice and rounded out. And so there's many examples. So you can imagine that if you're explaining to a patient what's going to happen in your procedure, then when we stop telling the patient what's going on, so when we actually have finished our explanation, we finish our explanation not because there's some outcome or endpoint that we've reached, but because we feel like the patient understands. So if we're using art in that example, then what we're actually doing is we're explaining to the patient that what's going on with their bone scan or their x-ray or their CT scan. And depending on that individual patient who might have more questions than others, they might be more or less anxious, they might be more intuitive themselves, they may have been a patient that actually has had it before, they may have looked stuff up on the on Google, and so you might actually customize what you're actually saying to the patient and finish it a bit quicker because one patient is fairly switched on, and you might actually provide a more deeper explanation or go over things multiple times or deliver it more simply because a patient is anxious. If that was science, you'd be going, okay, here's a rehearsed speech. Once I actually get to the end of what I've actually trained and rehearsed, then the job is done. So it's not customized. And so we think about all those aspects of patient care, communication, how we work amongst team members and collaboration, how we manage people and negotiate any conflict resolution that we go through in the workplace with students, with patients. How we do risk assessment can be a bit of an art form. There can be intuition built into that. Dose dispensing in nuclear medicine. So for nuclear medicine folk out there, is that just to have a feeling that you need to draw up 0.5 mils and be fairly close to being right without having to calculate it, is built on some intuition, the art of just knowing, having done it so many times. Protocol variations when a patient comes in and you just know that you're going to have to do something different, whether it's, you just get a sense that the patient's claustrophobic without being told. You get a sense that the patient needs closer supervision because they're going to be non-compliant. All these sorts of things are these gut feelings, this intuition that is built up over many years of experience. Image manipulation and reconstruction. So where to put our cutoffs when we're doing a reconstruction, you're looking at low pass filter, how many iterations that you might use. So there's a lot of manipulation that goes on in the images and image display and reconstruction that has a bit of an art to it. It looks good, it feels like it's done, it feels like it's complete, and so that's the art where we're going to call a job done. And of course, some people are very proactive. They see problems before they occur and they put things in place to prevent the problems from escalating, and that's a bit of an art form in itself. And so there's a number of quotes that I'll use throughout this presentation, but here's one that's important. Intuition is the art peculiar to the human mind of working out the correct answer from data that is in itself incomplete or maybe even misleading. And in many cases in medical radiation science, intuition is the art of actually solving problems without any data at all. So you actually recognize a pattern that has occurred from previous patients or previous experiences that you need to make some adjustment, you need to accommodate something. And so you may have very little data at all. So when I actually start to think about intuition or art, it's about this feels right kind of notion. And what are the things that feed into that intuition? Your individual beliefs and values, and that comes from not only cultural beliefs and values, but the beliefs and values that have been instilled in you from family and from your training and education and your employer and your own professional growth. Feelings and emotions. So what feels right one day can feel very wrong the next, simply because of your own feelings and emotions, the way that you connect with the patient, your stress and your mood, as we know, can change those intuitive outcomes, your experience, the skills and knowledge that you have, the kind of training that you've had, and of course there's a whole bunch of subconscious kinds of things that input into your intuition and art that you don't even accommodate. So, and they actually represent a mix of all of those others put together. So you may actually make a decision very intuitively and very fast, and you don't realize in actual fact is that this has actually been a complex training algorithm based on years of experience and exposure to various scenarios that your brain has subconsciously recognized a pattern and said, this is going to be a problem, or this patient needs a certain adjustment. And so it's learned, it's inherent and it's evidence-based, but the way it manifests in the real world is actually subconsciously, so it comes into art and intuition. So then we start to think about the science, and the science tends to be informed by evidence. We're talking about evidence-based medicine, the technology, defined protocols with defined endpoints. So the goal is to produce endpoints that are reproducible in nature. Okay, so we get the same endpoint. If 2 or 3 people in the department do the same thing, they get the same endpoint. If you do the same thing at different times, regardless of your mood and stress and other things, then you get the same endpoint. And so the endpoint is predefined based on an outcome. So it's this concept of it worked rather than it feels right. So instead of focusing on the intuition of feeling right, it's about it worked. And so there's a whole raft of examples, and there is some crossover with intuition, and there should be for that matter. But development of protocols and procedures have a predefined endpoint. Compliance with legislation, compliance with protocols and procedures, they have a predefined endpoint. A lot of research that is done, particularly quantitative research, randomized controlled trials, they're actually stopped, or they're actually looking for an endpoint, and that endpoint is the end of the research or the end of the data collection. Developing strategic business plans, developing CPD resources, or chasing your CPD tasks and goals. It's a fixed endpoint. You're after a certain number of hours that meet a target. And in recent times, ARPA has tried to change that. So instead of chasing, 60 hours over, 2 or 3 years, that what you're actually doing is actually chasing not only those targets as a minimum requirement, but also need to be able to demonstrate that you learnt something along the way. So the new way of doing CPD is actually a mix of the science, the endpoints, the targeted endpoints, as well as the journey. So the stuff that you learn along the way. I mentioned before that risk assessments have an intuitive component, but they also have a science component. If we go back to the radiopharmacy, you can be intuitively drawing up a dose, or you can actually be doing fixed calculations. Radiation therapy doesn't rely on intuition to develop planning treatment for patients. So there's a rigorous quality control of those calculations and calculation-based protocols. Evidence-based practice, I've already mentioned. Again, image manipulation and reconstruction. It appeared in intuition, and it's appearing here again because there is a science to it. There are certain outcomes. You could be doing iterative reconstruction, and you could be actually going intuitively. I need to do 20 iterations. But it could go the other way, where you actually go, okay, I'm actually going to target a specific error. So once I get to this particular error, then we stop, regardless of whether it's 5 iterations or 1,000 iterations, that we actually have a particular outcome that we're actually chasing. And of course, quality assurance is all about meeting targets. There's outcomes, there's numbers that we're chasing. And if it meets the target, then everything is okay. If it doesn't meet the target, or it doesn't meet the outcome, it doesn't meet the number, then it raises issues around quality control. And this is just a little quote, I guess. I don't believe in science, I trust science. It's not about being a belief system, it's about a trust system. And that's just a different way of actually looking at it. And so if we think about that logic, so the science is logic, it's about it worked. Okay, what are the things that feed into that? Scientific evidence, protocols and procedures, things being done in a reproducible way, leadership and judgment, your expertise and your skills, the data, the richness of the data that you actually have, understanding and knowledge, and then of course policy that actually informs all those things. So these are the things that feed into the idea of its logic, or it worked. And so then that brings us to the idea of a craft. So good practitioners have a balance of science and art, and that occurs in almost all aspects of your duty. It's a continuum, it's not one end or the other. Some things might be a little bit more science weighted and some things a little bit more art weighted, but in reality is that most of what we do actually has some balance of the two. So we define our roles in medical radiation science as being a profession. And so when you start to think about it as a profession, when you actually get the right balance of art and science, it's something that's more than a profession, it's a craft. And we talk about, your different, witchcraft or, other professions where you're actually crafting something. And the idea is that, that idea of witchcraft. What is witchcraft? It's this idea of art and science that creates magic, right? So it's actually this perception of creating an illusion. And so we can craft our career, right? So we don't just build our career. If we're building it, we're laying foundations and then stacking things onto each other. It's actually just following a logical sequence. Whereas we craft a career, okay, as a good career is crafted, you actually have those logical components, those bricks that are laid on foundations, but you also have something that's intuitive. There's this art to it that you need to be able to change direction and change the color or change the pattern or change the style as you negotiate the logical component of the career building. You also have something with a business plan. A really good strategic business plan is not built on science alone. It's actually crafted from a balance of logic and intuition. And so, leading on from the idea of witchcraft, magic is a craft. If you think about what magic is, it's the application of science and art to create an illusion which you would not have the outcomes expected if you relied on one or the other. So if you were doing a magic show and all you did was rely on the science, it'd be just a science experiment, right? People would be going, okay, that's fantastic, you made something go purple. If you relied on the art, people would get caught up in the show. It's the entertainment. And people would actually, it would reveal that the magic was not real. But to make magic look real, to make it the illusion happen, you've actually got to use the art, the show, as well as the science that then hides the truth. So it's actually, that's what magic is. It's a craft. So the duties of a medical radiation scientist demand a balance in the command and exploitation of both art and science. If you're all about science, then you'll be at one end of a spectrum, you'll be good at your job, but there'll be aspects of your job that you have poor command of. You may not have really good communication skills with your patients. You may not be able to troubleshoot. You may not, have those intuitive skills that allow problem solving. If the other side of it, where you're too heavily weighted in the art, then you might have really good patient skills, you might be a really good communicator, but you actually lack the abilities in some cases to actually get the outcomes that other staff members do. And you may not be focused on those outcomes. And so, people sort of talk about, the craft or the science. Science is, ruining everything since 1543, unicorns and flat earth and all those other things, right? Magic is just the stuff science hasn't made boring yet. And so, there is this perception that science, takes the fun out of the art. It takes the fun out of the magic out of the art, and it shouldn't be that way. It should be a mix of the two. We want our patients coming in to our department, and we want them to be thinking that we're doing something amazing. We want them to think that what we're doing is magic in some ways, but we need them to understand that it's actually crafted in this rigorous science that means that they're safe and it's has good accuracy and good efficiency, and they're going to get good outcomes for their health, but also that we have this command of the art that actually makes it, a welcoming and culturally safe and, mentally safe and a good experience and something that they'll actually value in terms of being able to integrate into, the outcomes that we generate for them with the science. And so, the quote on the right side, obviously from Harry Potter, I wish magic was real. Science just makes the world so boring to me. And these are all the wrong way of looking at it, is that science is only boring if we don't mix the art in there. If we focus purely on science, it can become boring, not to, everybody, but it actually can take the spark out of it. And what the art does is brings the spark back into the science. So we actually have this magic, and the magic is what we do as a job. So as Albert Einstein said, the intuitive mind is a sacred gift, and the rational mind is a faithful servant. But in society today, we actually spend too much time honoring the servant and not enough time focusing on the gift. And so the message in this is that intuition and logic go hand in hand. You can't actually focus on logic so firmly that we forget what a gift intuition can be. And when we start thinking about the craft, I think that these are a couple of good quotes. One from Ernest Hemingway. We're all apprentices in a craft when no one becomes the master, and that's probably true. If you think about life, all those things that we actually do, that we actually craft a business plan, we craft a whole bunch of things, and even when we have good command of art versus science, art and science, then do we ever really master anything? The life is so short and the craft so long to learn. And I guess that's the point. That do we have enough time in our jobs, in our careers, in our life to truly master something? Or are we all just apprentices moving along at a different part of the spectrum? And so if we come back to another diagram of the brain that sort of creates left brain, right brain, and look at that, intuition versus logic. And so on the right hand side, patience and concentration and constructed thoughts, analytics, effort, reason, right? It all comes with time, a time to think things through, time to problem solve with thought and evidence. Whereas on the left, we're talking about intuition and involuntary control. It's effortless and you're using innate skills. It comes with reflex and speed. So you're problem solving intuitively. You just know what the answer is, and you might be wrong. But it comes with pace, that you're actually solving problems on the fly as they go. And this is one of the classics that images that try to tie together science and art, where obviously the science is represented numerically on the, certainly via equations on the left, and art via this color on the right, and that the combination of science and art create what I've been describing as this craft or this magic, but in this particular scenario, that the junction of science and art creates wonder. And that's really what we actually do. Think about the times when we're most proud of our profession. We're most proud of our profession when we actually bamboozle someone. Someone comes in and goes, "That's absolutely amazing that you can do that. How does that technology work? I don't understand it. It is just amazing that you can do that." And it might be a patient, it could be a family member or a friend when you're actually explaining the job that you do. And they go, "That's just incredible." And we're actually proud, not because of the science, not because of the art. We're actually proud because of the wonder, because we're actually seeing people that are looking at the job that we're doing as magic. And it's only magic because we have this command of the science and the art. And so if we actually start to think about how that might look schematically, if we're trying to craft competence, okay, so we can actually have things that are predictable. So we're crafting the competence in us doing our job. Things that are predictable, right? We use our logical brain. We do the quality control the same way every day. Okay, patients come at the same time, it's the same dose. There's things that are scheduled, there's things that are predictable in our jobs, and that's all the logical brain. And then there's a degree of complexity in our jobs. Things that change from one day to the other, from one scenario to the other, from one patient to the other. And that requires a degree of flexibility that comes with intuition. And so if we break that down, you can actually see this logic curve that looks at the predictability end of things, and the complexity curve being looked at with intuition. And I actually kind of like this. When I looked at this morning, I thought about artificial intelligence and where that fitted into this. And when we actually start to think about human intelligence, we're actually really lucky, because we actually have this innate ability to think logically and to problem solve based on evidence and numbers and those sorts of things. And that's what this logic component is. If we think about how we might provide evidence of that, we would actually provide evidence of that with statistical analysis, students' t-tests, chi-square analysis, those sorts of things. Whereas at the other end, when things are really complex, we do rely on our intuition, and the human brain creates the intuition. And as I explained on a previous slide, is that a lot of that intuition is actually not just gut feeling. It's not this gut feeling. It's actually something that's occurring in your subconscious, and it's actually been learned. It's actually a process that's been learned, it's been measured, excuse me, and it actually has results that can be measured. And the way that we actually think about that is that in your brain has actually had a whole bunch of experiences that, without us being actually able to logically or consciously think about, it has actually connected the dots between seemingly disparate events, notice a pattern, and then be able to make a prediction from that pattern. And as a result of that, it creates this intuition, these things that we've learnt but we don't realize we've learnt. And that's actually really good for complex scenarios, is our intuition. And sometimes it's actually linking a previous experience with something that's similar. So it's not the same thing, but you're actually managing, you feel like the best way to manage a particular problem is the same way as a similar problem that occurred a few years before. And so when we actually think about how we'd provide evidence of that, we can't. It's based on outcomes, not endpoints, but it feels like we got a good outcome. Everyone's happy. We solved the problem. We stopped the confrontation. We got whatever. Everyone feeling good about themselves. But if we start to think about how artificial intelligence works, the application of artificial neural networks, machine learning, and deep learning, that's where this complexity comes in. So if normal statistical analysis is really about that predictability component, then neural network analysis really is about the complexity. It's about processing data in the same way that the human brain would, except we can actually peel back the layers and see how it's thinking. We can see the numerical attributes of learning that make us realize now that intuition is actually a lot more science than we might think. So the art, while it looks like it's art and it's going to be random and flexible and all those things, is a lot of that art, a lot of that intuition is actually very, very scientific in nature in terms of the way that our brains have actually convolved it. Not all, but in part. Just a different way of thinking about it. And so when we try to bring that magic or the craft together, we want to actually start to think about the job that we do in medical radiation science. Not only did it work, but it feels right. Okay, we don't just want one or the other. We don't want it just to work, and we don't want it just to feel right. We want it to do both. So optimal outcomes are associated with this sense that we've been able to craft our intuition and our logic together so that we end up with this magical outcome of it working and it feeling right. And so everyone has seen this quote from Arthur C. Clarke. It's probably one of his most famous quotes. Any sufficiently advanced technology is indistinguishable from magic. Okay, so the craft of medical radiation science is to make the magic tangible. Okay, and when we think about, our patients and our friends that are from outside of our industry, when they look at what we do, is that the technology is so advanced in terms of their understanding, not necessarily not your understanding, but their understanding, that it looks like magic to them. And so it's an opportunity for us to, as professionals, we're proud of our profession in medical radiation science. So it's time to celebrate the magic of our profession, and at the same time consider how we might craft it into, our professionalism, enhancing our professionalism. So I'll end there, just with obviously this notation that, or this question, something to go away and think about, is that, can art add color to, black and white thinking? Some of us are more black and white in our thinking than others. I tend to be quite binary, so I tend to be black and white. And so can art add some color to that? Or if we look at the image on the right, does science already add its own color? And so we need to really think about that when we're critical of people who are a little bit black and white like myself, is that don't assume that when they look at something that they're just seeing things in black and white. Is that what they celebrate as art might just be a little bit different to what you see as art. So one person looks at art as being this color, this painting, this vibrance that is associated with how something looks. And for other people, it might be actually, peeling back the layers and actually looking at depth of information rather than color itself that actually adds the color or the vibrance to a particular image. So that's just something to think about, because it's about diversity, not just cultural diversity, but we all think differently too. And if we look at some of the problems in the world, is that some of the problems in the world we focus on being, racial in nature or gender in nature or other forms of discrimination or inequity. But in reality, is that many of these issues come back to the fact that we just see problems differently. We see different perspectives, and understanding that people look at the same image and get different things out of it might actually help us to solve a few problems in this world as well. Anyway, thanks for your time. I hope that was interesting and just a different way of actually looking at our profession.